This is fluid coding and AI. GLM 4.6V Flash looks like the local vision model a lot of developers want, small enough for LM Studio, private enough for screenshots, and marketed for multimodal tool use. But in this LM Studio benchmark run, the broad assistant score landed at 36.69%. That gap is the review. The question is not whether ZAI has a weak vision model. This run cannot prove that. The question is narrower and more useful. If you load xi.org/GLM 4.6V Flash through LM Studio, should you trust it as a local coding, reasoning, research, and everyday assistant? By the end, the answer is not a blanket no. It is a careful maybe with a lot of caveats. GLM 4.6V Flash is the lightweight 9B model in the GLM 4.6V vision language family. Official ZAI and Hugging Face sources position it for local deployment and low-latency applications, while the larger GLM 4.6V is aimed more at cloud or high-performance cluster use. The family is described as accepting video, image, text, and file inputs, producing text output, and supporting a 128K context length. The LM Studio listing is what makes this model interesting for local users. The page labels it with vision input, reasoning, and trained for tool use capabilities, and lists an 8 GB minimum system memory requirement. LM Studio also matters because it is not just a chat box. It can run a local API server, expose OpenAI-compatible endpoints, and keep downloaded model chats, document chats, and local server requests on device. For a vision language model, the practical promise is bigger than image captioning. LM Studio's TypeScript SDK documents image input through prepared image handles for JPEG, PNG, and WebP files. The official GLM 4.6V story also emphasizes native multimodal function calling. In plain terms, screenshots, document pages, and visual tool outputs can be part of a tool use loop, instead of being converted into text before the model sees them. That tool use pitch is also where local reality gets complicated. LM Studio supports tool use through OpenAI-compatible endpoints, but its own docs warn that smaller models, or models without native support, may format tool calls incorrectly. Results vary by model. So even when a listing says trained for tool use, the working system still includes the runtime, the chat template, image plumbing, parser behavior, quantization, and the model itself. Now the benchmark. The local report is labeled All Benchmark Suites, and the workspace identifies the run as LM Studio with xi.org/GLM 4.6V Flash. The overall score was 688 out of 1875, or 36.69%. That is not a public leaderboard result. It is a first-party workspace artifact from one local run. But it is still useful because it tests the kind of broad assistant behavior people often expect from a local model. The coding category dominates the point total, and the picture there was mixed. Coding scored 675 out of 1803 across 21 cases. Several tasks failed but earned partial credit, including an 80 out of 100 setting service, a 70 out of 100 JSON log summarizer, and a 65 out of 100 config merger. But 3 coding cases hit long timeouts, including 2 medium tasks at 2400 seconds and 1 hard task at 3600 seconds. Outside coding, the result looked much weaker. Data interpretation scored 3 out of 12. Planning operations scored 4 out of 12. Quantitative reasoning scored 1 out of 12. Safety policy scored 1 out of 12. Source research scored 2 out of 12. And writing editing scored 2 out of 12. Most cases in those categories failed, with only a small number of one-point tasks passing. The biggest caveat is that this was not a vision-first benchmark. The report does not show broad image, document, or video understanding results. It also does not identify hardware, LM Studio version, runtime version, quantization, context length, sampling settings, prompt format, or whether vision inputs were part of the cases. So this run cannot prove that GLM 4.6V Flash is bad at visual understanding. It can only show that this local setup struggled across this broad assistant suite. My read is this: GLM 4.6V Flash remains interesting as a local multimodal experiment, especially if your priority is private image and document workflows. But this LM Studio run is not strong enough to recommend it as a broad local agent, coding assistant, research assistant, or safety-sensitive helper. For that use case, the benchmark says retest before trusting it. Different backends, full weights, quantization choices, and runtime settings could change the outcome. The next fair test would be more controlled. Use explicit hardware notes, LM Studio and runtime versions, quantization details, context length, prompt format, and sampling settings. Add a vision-first benchmark with screenshots, documents, charts, and interface reasoning. Then compare the same prompts against another small local VLM. That would separate model behavior from local packaging, runtime support, and benchmark harness friction. So the practical verdict is simple. If you want a small local vision language model to experiment with in LM Studio, GLM 4.6V Flash is worth a careful look. If you want a dependable local assistant for coding, reasoning, source work, planning, writing, or safety-sensitive workflows, this benchmark is a warning sign. Treat the model as unproven in that role until a cleaner retest says otherwise. If this helped you calibrate GLM 4.6V Flash before spending time on a local setup, like the video and subscribe to Fluid Coding and AI. I cover practical AI models, coding tools, and local workflows with the receipts kept close to the claims.